bummer. So I was saying, most of us are here for the fun element, I believe. Right, right, right. Say yes, say yes. There is gonna be fun. Amazing. So, data pipelines. What do you think when you imagine something as pipelines, be it data, be it anything that you see in your day-to-day life? Any answers to that? Anyone like to be enthusiastic audience there? Anyone working with data stuff? Anything? Analyst, engineer? So, what are your thoughts on pipeline? What do you imagine when you see a pipeline? Okay, interesting. So when my version of pipeline is Lego blocks. We love Lego blocks. And it has the ability to scale up, scale horizontally, make beautiful things out of it. You can have different shapes and sizes and colors, and that's what the bottom of the screen is trying to interpret that, the data pipelines and the fun element to it. So in today's session, we will be talking a lot about what exactly a data pipeline could be. Like, it could be a simple series of sequence of operations, or it could have a lot of downstreams operation with lots of orchestration, lots of complexities involved. Then we will see a simple recipe to say what could be the 5 simple steps to make a data pipeline, not overcomplicating it, having a simple architecture. Intro to open source data engineering tools. The third element would have all the interesting bits and pieces. The demo, how you could actually go from 0 to 1, and then 1 to n, as you prefer. Demo, I will have a time check for myself and see how much we could squeeze in that time. And then finally, the takeaways. What do we have as the end goal of the session? What are the takeaways that we can have? Moving ahead, a little bit about me. This is me, art, nature, and notes. You throw me art, I'll paint with you. Hikes, anyone interested, and notes, yeah, amazing note taker if anybody has a session and needs the transcripts thing. I'm a data engineer at my day job at QuantSite, project incubator member at NumFocus. NumFocus is primarily a corporation which helps in funding open source projects. You might have heard about SciPy, NumPy. Those come under the umbrella of NumFocus. I'm an organizer at PyLadies Bangalore, India, a community-driven initiative for underrepresented folks in and around the world. So if you are interested, I would love to talk more about it. DNI member at Python Software Foundation. I do a lot of community-driven work, both in my time and whatever free time I have. And finally, I'm a contributor to NumPy and SciPy open source. With SciPy, I normally do the developer experience and elevating it. What are the different bits and pieces that we can perform in that? More my website, and you can definitely take a look there. So, internet in few seconds. You could probably click on type that link on your computers and your browsers, and you will be redirected here. So when today we think about internet is about data. We see data is the new gold. Data is what is driving most of our kind of economy, most of our enterprise softwares, and everything is sort of related to data right now. So here I love the example from Burger King. So every 8 seconds, 626 burgers are sold. It's kind of a worldwide statistics, but it always changes. So I took the screenshot a couple of weeks back. So now you might see a different stats. The way the enormous the data is today cannot be fathomed like 5 years back. So how exactly we deal with all such amount of data? What should we do? Should we increase the complexities and make it so difficult to interpret that, hey, only a few selected group of members were able to understand that? Or we break it down and we simplify it and start from the very beginning, simplify the concepts, simplify what we think about the data pipelines are all about. So that's primarily the source and inspiration of this session, simplifying things, not overcomplicating them. In the background, this is how my day-to-day life looks like. On Slack, hey, where is the metadata? Did you forget it? No, I haven't forgotten it. It's just not visible there. I have just not logged it. Oh, have you done the partitions right? No? Yeah, I have done the partitions right. Let's use this tool, let's use that tool, and together we will have a stack of different tools that makes life overcomplicated, and finally, everything is broken. So the end goal is not to overthink and over orchestrate things and have different sorts of batches and streamings at different time zones, and they're coming in and deep diving in your data lakes or data warehouses. And at the end, what we fail is to write tests. Yeah, that's one of the pain points in data engineering world. Like, we forget to write tests. Tests are important in software development. Tests are important in data engineering world. Is your source ready to consume or give out the data? Do you have the right schema of the data? How do you analyze all these things together? So you have to write a lot of tests. And then when to use big data and when to not use big data. So these are the 4 V's that one should keep in mind. Volume, velocity, variety, and veracity. These are the 4 V's. If you have any 3 of them, you're good to go with a big data application or have a lot of different sorts of partitioning in. But if you don't have them, then probably you don't need any of this cool stack that we will see in one of the next sessions. And probably what you need is simple, you are using a simple CSV file. That's how most of the companies start. Take that CSV file, ingest it in your maybe database, query it using SQL or normal pandas, Spark, Dask as you prefer, and then use dashboarding, ML pipelines, ML ops, and from there it continues. So that's the life of a funny data engineer. You balance this, you balance that, and finally there is a boulder on your top and like, hey, you are squished. That happens pretty often, like things break, the production. 5 simple steps. This is my version. Select your sources carefully. Sometimes the sources are redundant. So when you select your sources, make sure what exactly are you having those sources from. The first thing, are they reliable? The second thing, how are they secure? The third thing, are they redundant? Like, there are multiple sources. For example, you are using, suppose, Zoha, Zendex, CMS. Most of them might have a similar set of data. For example, maybe employees, the employee data. Do you need all of them? No, you just need one. So make sure you clean it before you ingest it in your pipeline, because this is the one of the most important step where engineers fail to calculate their data size, the benchmarking, and they get into the trap of ingesting everything together. And at the end of the day, when you have everything dumped in your own lakes and warehouses, you just don't know what to do with that data, because yeah, you just dumped it. Quality control, very, 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 very important. You have to write quality control and testing. Okay, before even writing your business logic, you have to test the data. Is it what you wanted? Is it something which is needed for the exercises that other teams are going to do? For example, you might have different data lakes, you might have different warehouses, and you could just have one S3 bucket with everything dumped. Choice is yours, but write quality control test. That is important. Then the third thing comes is the business logic. What is your ETL gonna do? Is it gonna do an aggregation function? Is it gonna just select everything and throw it on a dashboard and let the ML engineer suffer? Or the data visualization people, let them clean it? That's whatever goes in here. Orchestrate. Now that you have ingested from the source, how often would you like to do that? If it's a stream, yeah, Kafka. We heard about Kafka today, so you can use Kafka. But if it's a static data, you could probably just dump the CSV file every week or every month, depending on your use case. How often would you like to do that? It's in theory, the financial datas are like quarterly reports and everything kind of goes every quarter, the updates happen, while something like messages, something like voice messaging stuff has to be done every day, every second. So there the complexities increase. Orchestrate and then update, break, and continue. Don't sit there. Now that you have built your ETLs, it's important that you keep on updating it. Make sure that it breaks. Yes, it breaks, and then you continue to update it. Learn from those mistakes and do that. Even none of the leadership or management would kind of credit it for breaking stuff. But at the end of the day, it's important to know the flaws that goes into the system. No system is built with 100% accuracy at the first go. Iterate. It's important. Yeah. These are the tools that used to exist in 2021. The list is so huge that it's not possible for me to fit in one slide. But here is one example how the world of data visualization, ML ops, data engineering, just governance, from when it started and from where we are now, the amount of tools the list is gigantic. And often companies and, for example, small startups, when they want to make something very simple, they stumble upon, hey, Netflix is doing this. Probably we should pick those tools and just replicate what they are doing. It won't work. One size doesn't fit all. That is one of the key takeaways. Make sure that you have your benchmarks in, even when a small startup project starts. What are the benchmarks? So we have, this is my complexity, this is my time complexity that I'm expecting, this is my space complexity that I might be expecting for a time duration of, say, 2 weeks. That's a good enough start. And based on that, each of the tools have different things to offer. So in today's demo, what we are going to see is a very basic example to get you started. Have a framework in, have your pipelines running, have your dashboards coming in right in there, so that you have the framework ready, you have the base of the Lego ready. Now you can create your building, now you can create your own cars if you like cars, or whichever architectural monument you would like to create. We can go from there. So many choices. This was me most of the time when I was asked to, hey, just choose the tools that you would like to have. And I'm like, okay, I'll pick that, I'll pick this, and pick that, and smush it and give you a demo. And after some time, when things get huge and I didn't have any benchmarks, everyone was like, Sayantika, what are you doing? You should have picked something that kind of relates to our goals, our vision. But yeah, you have to give me that time to do that. Handy open source tools. So in today's example, we will be talking about a bunch of tools. This is not an exhaustive list, but enough to get you started. That's the agenda for today. Conda. Anyone familiar with Conda, using Conda? Perfect, I see one hand. Anyone else? No. Pip. Yeah, Pip fans. So we are gonna use Conda just because I don't have to worry whether it's just Python, it could be Python, it could be Scala, it could be Java, anything. So you don't have to worry about that. And it's pre-packaged binary files, so even you don't have to do the resolution on the fly, but you can go back and it's done for you. Also, Conda is very reliable, fast, clean way of package management and environment management. So we'll be seeing that. Then this little person here is, anybody familiar with this? Guess the name. No. It's GitHub Actions. So GitHub Actions is, we have seen a lot of different talks today and yesterday about CI/CD, DevOps, and yeah, we are gonna write a little bit of YAML here and put every other aspect of the data pipeline testing, data pipeline environment creation into the CI/CD. CI/CD will go through and it will say, is it failed? Is it okay? And we will continue from there. Then this one, this little guy, we all love, yeah? GitHub fans, stickers, GitHub stickers fans. It's me. I love their stickers. So GitHub, we have a repository already. So the repository will be with, you can also go through that link. And if you're comfortable, create the environment and start using it. So it's already done. Intake. It's a beautiful open source tools that let you manage both the metadata, your different source files, and also let you create your own drivers. So suppose not every file is a CSV file or an Excel file. What you can do is create your own driver to read that, and it's very, very simple. It also comes with a GUI, graphical user interface, where you can load the source system and you can see what is the schema of it. So we know in the industry, it's not just about developers, it's a collaboration between developing teams, sales teams, business teams coming together and making something. So you always would like to have which is simple, which is functional for everyone. So a GUI is one of a very beneficial way of having a good collaboration between different teams. And I love this. It's Daxter. Daxter today we will be seeing as an data engineering all-in-one thing, which helps you orchestrate, which helps you kind of do all the other aspects like logging management, orchestrating. It also comes with amazing Dagit UI, which we will seeing in action. And pretty much everything that you can think about those 5 steps we talked about, you can do it with Daxter. And the code is simple, and we will see how we do that. So Conda, this is one sample file on the screen that you have, and the links will help you understand a little deeper, but basically we are using it for everything environment management. So here is a sample name, what the environment file looks like. I'm using the default channels as CondaForge, so you can have node defaults, or you can have your own pip channels also written here. I'm sticking to 3.10, yeah. We don't want to use something like 2.7. Anyone 2.7? No, that's good. Oh, I see someone. Then as we talked about intake, then we have a bunch of different files that I needed for my development, but feel free to add yours. Amazing stuff. You can still use pip. It's not that I'm asking you to eradicate pip. You can still use pip packages and kind of add a similar entry and put all your pip packages there, because not everything is available on CondaForge, so you can use that. Next up is intake. So as the definition, it's very precise. It's a lightweight package for finding, investigating, loading, and disseminating data. I have an interesting story to tell. When one of the organization I entered, they have nothing about what is their source and what is their destination, from where this data was coming in, from which table it was going, from where it's been taken out, and where it's dumped. All those information was missing. So with intake, you can write a simple YAML file, as we start with a version, name it as a version. What are your sources? So for me, there is an address sample, which is a CSV driver. Intake comes with handy drivers. Here I'm using CSV. You could have JSON. You could have, suppose, Excel. So all those are pre-configured with intake, so you don't have to write your own custom code. Only thing that you have to do is .read, and it reads any file. Even Parquet, OCR, if you have big data systems, it will do the job flawlessly. Here we are using something from the internet. So as you can see, this is the source, which is an HTML page. And from there, I'm calling this address.csv. So it just sits on and some other server. I'm just pinging it and using in my demo. Then I have something the stock price data. If there are financial enthusiasts who like to play with stocks, and if they're down, yeah, they're always down. Nothing is rising up now. So you can have that, and I have taken that, saved that data in my own repository, and I'm reading that. So there are both the ways of doing things here. You can either have it somewhere in your AWS bucket. The only thing that you have to change is add your tokens. You have to configure your tokens, and they are good to go, and you can just use the same example. Another thing, if you would like to have it in your local, like I wanted to have in my local, then yes, you can just have it in your local and read it from there. There are different ways of doing it, and these are just a few of them. Now, GitHub Actions. So all this screenshots and everything will be, I think the slides will be available to you, so don't worry about that. And the repository is also up and running, so you can play around with that as well. GitHub Actions. Again, we will take a lot of help from our dear YAML. What happens on push, what happens on pull, how is the environment managed. So for example, if you are using scikit-learn and you have not added in your environment file, and you have pushed it to the production. So this all this stuff would be stopped, and you probably have a safe way of doing things, like the CI/CD would run and say that, hey, this package is not in your environment file, probably update it, and then we will move to pushing it to the production if you have a CI/CD doing off mechanism. If you're manually doing it, I suggest that's okay. That's your choice. You can do that. And this is amazing. So everything is in one single platform, so you don't have to move from one platform to another, and pretty easy to get started. And then Daxter. The example we will have is going to use the stock price that we saw in our intake catalog, and what we are going to do is do a simple read and a simple clean. And we have built a simple 2-block pipeline. It could get complex. I will also show you a little complex pipeline, and it goes beyond that. So yeah, whatever you can imagine, you can do it. Not just data engineering things. For example, I have an example where I am also using clustering in my data pipeline, because the end output that I want is take the data, clean the data, find the features, do a little cluster analysis, save that cluster analysis file, and that file will be used by the data visualization engineers, so that they can find the clusters, because they want to have an easy job. So even that can be done. So there is no limits. You can go crazy, and yeah, go crazy. Yep. Yeah, I said crazy, yes. Now, launching a Daxter run. We talked about Daxter. This is how the UI looks like. But let's start with the two important components, and we'll see them in action. So Daxter in the backend uses ops. Think ops as little tiny beads, job as a thread. So the end goal is just making maybe a garland or a necklace. So you stitch those small beads into the thread, and you make a jewelry out of it. And that's basically a series of operation that happens. And the technical definition is something like this, which you can read from here. But the understanding is like small components are the ops, and when you want to combine all of them, you have to put it in a job. Op and jobs are two constructors which are used in the Daxter pipeline. The code, yes, the backend is happening. You can also see the code if you're interested. The most interesting part for me is this. When I launch my pipeline, for example, we want to kind of benchmark if my read is not taking, like, suppose, greater than 10 minutes. I want to improve on that. This is one of the handy ways. There are multiple other ways, but it comes with an inbuilt UI where you can see it just takes a couple of seconds for me, and probably it's OK. But if I want to optimize it, you can see it from here and probably optimize in your second run. Then all your Log operations, for me, it's going in a file, but you can also have your logging done in a server, in the form of, in maybe an AWS bucket, whichever is your favorite one. And then I have everything coded for me, which talks about how the execution happened, is it computed or not. If it fails, we will see errors, we will see warnings, and we will see critical things. So it depends on your logging mechanism, what you are using. Timestamps. It automatically comes with the timestamp, so you don't have to worry about the time zone issues that you might be encountering in different time zones. Up next, a little bit of coding. Interested? So we can do that right now. How I'm doing on time? Pretty good. Perfect. Okay. So this is a repository. If you're interested, you can probably hit on this link down there, and you can reach to the GitHub repository. Currently, it looks something like this. It has a pre-built workflow, a package manager with it. It has the GitHub Actions already configured in the workflows. It has a framework. If you go inside, you will see different pipelines been already there. There is a doc. Basically, it talks about if you're adding something new, all the examples and experimentations goes here. Rest is all the basic stuff that we have it. And this is the environment file that is important. So in case you're interested in deep diving it, it's up and running, and you can take a look there. Now I'm going to run 2 pipelines, hopefully live demos. Never go right, but I'll try. So right now, I'm going to run a simple pipeline, and I'm going to run a complex pipeline, and let's see how both of those look in the Daxter UI. I'm doing just an ls, and my pipeline name is process.py. And you can probably find it under this pipeline and process.py. Simple code, nothing fancy, just it's reading the data, it's cleaning it, and there's a compute function that stitches all of them together. We go here, run please, it's been recorded, tag it -f process.py. Oh, it's running. Copy this little tiny URL, paste it in the browser of your choice, and hey, it's running in your local. What you can do is also write a Helm chart and put it in your servers, or as you prefer. There are different ways of deploying it. You can use Minikube or in your local, and also kind of deploy it using different, we read a lot about Kubernetes and Docker. You can also do that here. Now we'll do a launch of what are the elements here. I click on this tiny button. This tiny button is not coming on the screen, but there is a launch button in the bottom of the screen when you run the Dagit UI. And here, it shows there is roughly 1.5 seconds that it took to read the stock data price. It's about a couple of MBs. It's not huge. And then I did a clean names column operation on top of it. And there it is, every result up and running, clean way of defining your data pipelines. And also if anybody, apart from developer teams, would like to check it, how the pipelines are performing, you can also configure messages, which directly goes to your inboxes. You can have text configuration in case of critical failures. All this could be done with Daxter. So any questions until here? Like just on running it, or maybe anything specific you have in your mind? Any questions? No, everybody understood everything. Cool. Now let's see a little difficult, not difficult, a little broader pipeline. So I'm gonna do the same command. Oh, the important part is I'm using 2 different environments. Oops. two different environments. Here I'm using a capstone environment. Here I'm using, where are you? Clear, yeah. Here I'm using an environment called Journey. The code in the repository that you have will be called as Journey. So the other example is not available in that. It's something I'm still working and exploring. I'm going to do the same thing. Probably here, copy things, Control V. There you go. This is a slightly complex data pipeline where you are reading the data, you are taking a subset, you're reindexing the data because, yeah, there are some daytime stuff that you need to do. You're doing a factor analysis, some machine learning stuff, then intermediate clustering just to check how the clusters look like. You're scaling the data, basically normalizing the data so that the end result is as expected. Then you're again using a clustering technique. Basically, we are using a k-means here to do the clustering approach. And finally, I'm writing the right cluster output. Let's see how the launchpad looks for this. So I'm gonna hit run cluster. Yep, it's big, and it will show how each of the op is performing in general. So you say it's running, it's doing its job, it's benchmarking, and all your logs are like on the fly, coming there. Voila, it's done, I hope. Yes, process run, executed, and it's done. Everything that you see could be like, you can have it specific. If you click on the block, you can see what is the output, what is the input, what happened in between, how much time it took. All of those things could be easily seen via the UI itself. So the wonderful part is you can play around with it. Send me some PRs. I'd love to see some PRs and improvements on top of that. So that's the session. That was the demo. That starts from a very simple application, goes till a little complicated and moderate level difficulty application. But you can go crazy. And please go crazy and build everything that you would like to build with these sources. That's me, probably most active. Second home online is Twitter. Send me messages if you like. And that's my website, probably to be updated. So working on that, but it's still up. That's the takeaway. I know, pretty general takeaway, but keep having fun. The world of data is ever evolving. That's what my experience kind of says. And you have to kind of explore different things, different tools, different techniques in order to come what works best for you. One shoe doesn't fit all, so make sure you do the benchmarking, make sure you write the test, and make sure to communicate with your fellow engineers and non-engineering teams and business about how would they want to have those UIs built on top of data engineering pipelines. It's not just visualization anymore. Data pipelines also needs a lot of visualizations and how it's performing, and it's a big chunk of the industry now. Thanks. If you have any questions, I am sticking around for some time. You can definitely ask me some questions. Feel free to drop an email. You will get that email on my website. Anything else that you want to share? Thank you.
Thank you, Sayantika. I like the last slide.